everyone, this is a video tutorial on the dehydration of secondary and tertiary alcohols. So if we take a look at the basics, we have either a secondary or a tertiary alcohol in the presence of sulfuric acid and heat, and this would form out an alkene. So basically when we say dehydration, that means you're going to be losing a water group. This is going to follow an E1 mechanism because a very stable carbocation will form. The major product of this will be the most stable alkene. Let's take a look at the mechanism. Okay, so let's take a look at the mechanism. So over here we have a tertiary alcohol. As always, the first step is to activate that OH group so that we can kick it off later on in the reaction. So this group will come with the electrons on the O and attack this hydrogen, giving the electrons over to this O. So here we have a protonated alcohol. The next step will then be to kick off that OH group and form a carbocation. Now remember, when we're doing an elimination, it's always a good idea to label your alpha and your beta. So alpha is either where the carbocation is or the carbon that's attached to where the leaving group was. And then alphas have betas. Those are the carbons that are adjacent to that alpha. So over here we've got these two betas which are equivalent, meaning that they would form exactly the same product whether I pulled a hydrogen off of this beta location or this beta location. I do have a different location though, and that's this beta carbon. So I can either have my hydrogen pulled off from here, or I can have my hydrogen pulled off of there. We will look at both cases. So over here, my water group that I kicked off earlier will come, attack the hydrogen, and drop those electrons down between the alpha and the beta, giving us this as the product here. Alternatively, my water could come, attack this hydrogen, and drop those electrons between this alpha and this beta, giving me this product. Now I know that this is going to be my major product because it's a more stable alkene. It has 3 R groups coming off of it, whereas this alkene only has 2 R groups coming off of it. And that's how these mechanisms work.